My name's Rolando Panez. I'm a DevSecOps Architect for Checkpoint Software. Previously, I was a security engineer, so I've seen the transition, from on-prem to cloud, and from servers to VMs to containers, right? As we've all seen. So it's exciting that all this new technology is coming about, and things are moving so quickly. So with starting to talk about shift left, and what I'm going to talk about here really is security and how it's changed over time, right? Just briefly about Checkpoint. Checkpoint's been in the security business for over 30 years. As part of being in security, we have one of the largest threat intelligence databases in the world. You can see some of the statistics here, and it's really the core of our technology these days, with everything moving so fast, understanding how attacks work, right? Leveraging a lot of machine learning and AI with all this data, right, that we share amongst all the security vendors, right? So Trend Micro and Palo Alto and CrowdStrike, we all share this information, and we use this information to help protect our customers, right? So we've seen things evolve from the network to your mobile phones to your endpoints, right, now to the cloud. And again, having this database, having a very functional data that we can use within the environments, within different points of your development process is key to keeping your nowadays your supply chain secure, right? So first, let's understand the security around cloud native, right? Cloud native security, and being in security for so long, one of the biggest things I learned, the most important things, is that security needs to be simple. It needs to be simple in that you need to know where you're injecting or where you're scanning for things, right? Where you're putting your enforcement points, and then the data that you get out of there, right? Having the correct remediation steps, right? Having the correct information at all times is critical for security, right? If we make it complicated, right? If we use complicated languages, if it's not clear to understand, then you can miss things, right? So keeping it simple is key to security. So I'm going to start here with the Kubernetes 4C models, right? So this is from the Kubernetes documentation, right? The security overview of Kubernetes. And the 4Cs model is kind of the same approach that you had in your data center, right? Where you would do your layered security, right? You would have your servers, you have your enforcement points, you have your IPS in front of your servers, right? Different types of signatures from servers than you would from for your users, right? So there's the same layered approach. You have your network access control, then you have your firewalls on the edge, you have your endpoint security, okay? So you have this layered approach in the data center, and now you can transition that into what is cloud native. It's a little different, right? Now we're moving from a lot of hardware and software to mostly software, okay? And so if we look at the 4C model, right, which basically talks about the cloud provider, the Kubernetes cluster, the container, and the code, right? If you focus all of your efforts in security around the code and securing the code, yet you leave the infrastructure open, right? Then you've kind of defeated the purpose, right? So having this layered approach and locking things down at these different points is gonna help you achieve that overall security, okay? And so we're talking about the cloud provider, and really the cloud provider and the cluster. We're talking about the the posture management of those components, right? Ensuring that your RBAC is configured correctly, ensuring that your IAM policies are configured correctly, or if you're using VPCs in AWS, ensuring that you have some security gateway, right? You've locked down your security groups. There's a lot of checks, a lot of posture checking that needs to go on within these two components. As we move down, right, we're moving down into the container. Now we're looking at vulnerabilities. We're looking at this is really part of more of the supply chain, right? So did malicious files get injected into my container? Did or are there URLs within the container image? Are there vulnerable dependencies in the container image? Okay, these are things that can be exploited. And again, once something is exploited at any of these points, then you can move laterally, right, as an attacker. And then finally, the code, right? Code is critical as well. Are you following good security coding practices as far as if you're establishing communication between one application, one microservice, right, to another, are you using a secure encrypted communication between them, right? Also vulnerable dependencies, okay, vulnerable code. A lot of things that can seep in. Sometimes you get a binary that seeps in into your repository, right, to your GitHub. Typically that's not it's not best practice, but what if something does get in there? How do you ensure that you clean those types of things from your repo? Okay, so again, defensive depth, this layered approach, keeping it simple, right, is going to give you your overall security. And so with that, now we're moving into a lot of this transition, right, from monolithic to microservices to leveraging containers, serverless. All the folks that that talked before me here, a lot of it was around automation, right? That's really the key thing around DevOps, right? The DevOps culture is that everything revolves around automation. And so when you've moved quickly from into microservices and started leveraging containers and serverless functions and made all this automation and pushed software changes through very rapidly, right? Now, a lot of times security, is kind of an afterthought, right? You've had your typical points during the development process where you secure or where you do your security checks, right? You do your penetration testing. But now with things moving so fast and you have this small function that needs to get tested, needs to get deployed, right? You need that speed as part of security. So you need to start working and injecting and really educating the developers, right? And this is where that shift left concept comes from, moving from DevOps into DevSecOps, okay? So as you start educating your ops teams, your dev team about security and enabling them with very simple tools, right? Again, the security guys, security is that we want to get out of the way, right? They're telling us, stay out of the way, we're moving fast. Okay, so we're going to stay out of the way, right? We want to be part of the game here. We want to stay out of the way. And so we're going to provide some tools that our developers can use and start enforcing some of the security, right? Start catching some of these things early on in the dev process, okay? And so as we look here, within securing your pipeline, right? And Checkpoint CloudGuard is one of the solutions, but all security vendors have are looking, in this way of securing the different components, right? There's a lot of functionality on the deployment side, right? Everything, the EC2 instances or the VMs, right? Securing those VMs or your serverless or your containers, okay? But as you look more towards the left, right, you can see that there's posture management that can be accomplished very early on during your code and commit, right? Before you in your build process, okay? There's a lot of posture checking that can be done. And then when we're talking about developers, right, we're talking about IDE plugins, right? Some of the security functionality that can be plugged into their local environment, their local development environment, right? And if we think about, for example, Checkpoint Threat Cloud, how can we inject that at a very early stage? So how can the developers start using these tools, learn about security, right? Get the output they need, fix things very quickly, right? And be able to move on. So the information, the remediation steps that you get from these tools have to be clear and concise, right? So when we start talking about shifting left, okay, so now we're over here with the developers, they're starting to use these tools. What kind of things do we have to look for, right? And so when we start talking about source code, the scanning, the source code scanning has to be security focused, right? Not so much on comments and proper linting of the code, right? It's more security focused. Have you used obviously your CVEs, your CWEs? Are there any malicious binaries within the repo, right? Is there any vulnerable code? Like for example, have you used a secure communication, right? Between when you're talking to another component, to another microservice? Are you using? Is your code? Can it be vulnerable to cross-site scripting attacks, right? Or for example, you're using Flask in a debug mode, right? Do you have a hard-coded IP somewhere in your code that can be used as a denial of service attack, or maybe you have a malicious URL that's leaked in somewhere into your code. Okay, so all of these things are security focused, right? It's different from your traditional static code analysis for your source code. Okay, so finding this security focused source code scanning is important when you're talking about shift left, right, or shifting security left. The next step, and also exposed credentials, right? This is something that we deal with a lot. And again, like GitHub has a lot of this functionality already built in, right? But having those exposed credentials within your repository, we know is a big issue as well. Now, when we're talking about container images, okay, so not, a lot of times you assume, okay, if my source code, if my repo is clean, then I'm good, right? But you'll see that, and part of the supply chain attack is that any of these vessels can really be, compromised, right? You can inject at the container image level, right? You can inject a package at some point, right? Some dependency within that container image that could be vulnerable. So with the container image, you want to scan the OS level packages, right? Every Docker file starts from has the from line. So it could be from Alpine, from Ubuntu, right? From Python. So those base packages that come with the container image, those needs to be scanned. A lot of times they have vulnerabilities already included. Okay, so you want to make sure that the OS level packages are scanned, along with any application packages, right? So if you're adding additional runtime components into that container image, you want to have those application dependencies or those application packages scanned as well for any vulnerabilities. And again, we're looking for CVEs, we're looking for CWEs, right? And in addition to that, malicious binaries. Okay, so there's a lot of we're building on top of this source code. Okay, again, at this point during this container image build process, there are things that can be leaked into the container. And then finally, dependencies, right? You want to ensure that all of your dependencies, the licenses for your dependencies are in line with your project. Okay, and then we move on to infrastructure as code. Okay, and this is a lot of the posture management typically takes place at the deployment side, right? Your application's up and running, your S3 buckets are deployed, right? Your EC2 instances are running, your database instances are running, and then that's when you do your compliance checking. But when you're leveraging infrastructure as code now, you can actually do these checks beforehand, right? You have your Terraform, you have your CloudFormation, you have your ARM templates. Okay, all of these different components can be checked, right? They can be scanned using some compliance framework. Okay, so these are the kinds of things you want to look for when you're looking at infrastructure as code, and not just infrastructure as code, right? Recently, I had a conversation with a customer, and he said, you know what? I need to start securing my pipeline. How do I ensure that my pipeline is using these tools, right? So having those YAML files scanned as well, right? For inclusion of these types of scanning is also critical, right? So you want to use some compliance frameworks, right? Just like you do in the cloud, as recommended by cloud providers, you want to have those frameworks in place. Are you using CIS? Are you using NIST? Right? Are you using some form of best practice? And then you want to have your ability to make your custom rules, right? You want to enforce tagging capabilities, right? How are you tagging things, or enforcing namespaces when you're deploying your Kubernetes when you set up your Kubernetes deployments? Or maybe when we're talking Kubernetes, your security policies. Do you have the right security policy assigned or network policies? Okay, and these are all posture management components that can be included with the infrastructure as cloud. Okay. So now I want to shift a little bit over into, okay, so we understand the 4 C's. We understand the layered approach of security. Okay, we know where we need to start scanning, how we can start helping our developers get more educated in security, right? We know what we're looking for with these types of tools. And so now let's go from let's go into an end-to-end type of flow on the tools here, right? So if we look at, if we start again, like I mentioned, the developer's environment, right? The developer needs to know, okay, I can start using these tools. I can start doing a scan locally on my project before I even upload it to GitHub. Okay, I need to make sure that I don't have any credentials deployed in my or in my source code right before I upload it. Okay, so the local developer, again, this helps them educate. It helps you educate your developers, and keep in mind, the ultimate DevSecOps environment is where the developer understands security, right? They understand the findings, okay? They can remediate those findings and resolve those issues. That's the ultimate DevSecOps culture, if you will, right? But we need to start helping just the overall process of doing that, and using that local environment from that developer is critical to getting to this point. Okay. Then we move on to the CI/CD machinery. Okay, so I talked about your code, your source code, building that, building your container image, right? And then that container image moves on into your registry. Okay, and so these three components, these are the most critical parts as far as talking about the supply chain attack. This is where you need to scan every time, essentially, because at any of these moments, something can get tampered with, and you can get a vulnerability leaked in. Okay. From here, right? So this is really the shift left component. I'll just briefly talk about what we're seeing with when we're talking about the 4 Cs, right? With that layered approach, we still need some additional controls down the road, right? Where now we've scanned and we've contained any possible attack, right? We've contained it with our scanning at the different steps, but now ensuring that this resource is coming from the appropriate registry is important, and that's kind of part of your admission control when you start talking about Kubernetes, right? And then from there, once you have that admission control, right, you want to ensure that that container image is still continues to behave appropriately. And so this is where we start talking about some of the runtime protections that you can use within your Kubernetes environment. Okay. Ron, a little time check.
About 2 minutes, 3 minutes left.
Okay, excellent. Thank you. All right, and so then now I want to dive a little deeper into your threat vectors here, okay, and what exactly can happen at different steps, okay. So we're following up, with this end-to-end view, right? Keep in mind that malicious attacks or attacks of that supply chain can get injected either with the source code, tampering with the source code, or tampering with that Docker file, right? At the Docker file, you can actually inject, hey, go pull down this malicious binary, and maybe it's a DLL file, so it doesn't look suspicious, but it can get injected into your code. And by the way, this is kind of the supply chain attack that happened with the Sunburst and SolarWinds attack. Okay, when we're talking about the CI/CD machinery, again, recapping vulnerable dependencies, vulnerable images that can get created at this point, and then and modifying those images during build, right? That's attacking those images. And then if at that point any of these happen, right, then you have at the registry, somebody can tamper with your stored images as well. So you can see all the different threat vectors here when it comes to attacking the supply chain. So you want to be able to intercept some of these image pull requests, right? Or an image pull request can be intercepted and also be deployed into your or put into your deployment. So these are your different attack vectors and why the different components that we talked about are so important. Okay, and with that, I want to just summarize, right? Shift left, right? It's really talking about moving into DevSecOps world, right? You're transitioning from DevOps to DevSecOps world, helping educate down to the left, helping educate the developers, right? Playing nice with everybody. You want to scan your code in a security-focused way, as well as your containers, and then also do posture checking for your infrastructure as code, and handle a lot of those at a very early stage before it even starts getting built. Okay, and doing these things will help you prevent the supply chain type of attack. Okay, and if you're ready for the next steps, here's some links that you can visit. We have a demo of using shift left tools within a real pipeline. This is a GitLab demo that you can take this QR code, it'll take you to that page. And then some places where you can learn more about what Checkpoint is doing, at checkpoint.com/cloud. We have a developer site where you can get examples on how to implement security tools within your source code or within your pipelines, and then also our community.checkpoint.com, where we're constantly discussing these types of topics and presenting new solutions. So with that, appreciate your time, and thank you.